your original sample here, and you've done your serial dilution, okay, where you placed 1 ml sample into 9 ml of diluent. Then you carry out pour plating, where you placed 1 ml of your diluted sample into an empty petri dish plate, okay, and then you mix it with molten agar, and you incubate it, and then it started, and then you'll have things growing on it. Okay, so if the count here is, let's just say 250, and the count here is 20, the count here is 2. Okay, so what is the final CFU per mil? Okay, so you have to remember the first guideline. The first guideline states that the counts should be between 25 to 250 or between 30 to 300. Why did I include two ranges here? So this is the original USFDA range, okay? But for temperate tropical countries, most of the counts are usually higher, bacteria grow better. So for us, we will stick with the 30 to 300 range, okay? So please remember that. We'll stick with the 30 to 300 range. So if you get results like this, you see 250 colonies here, 20 colonies here, and 2 colonies here. So what do? What's the final CFU per mil? So only this count is within the range. Only this count is within the range. So it's 250 CFU per mil. 250 CFU. However, this is 1/10 of the original concentration. This is 1 per 100 of the original concentration, and this is 1 per 1000 of the original concentration. So you take this 215 CFU, you times 10 times dilution, okay, to give you 2500 CFU per mil of the original concentration. Okay, so this is 10 times dilution, 100 times dilution, and 1000 times dilution. Okay, this is also known as 10 minus 1, 10 to the power of minus 1 of the original is 2 minus 3. Okay, so from here, to get back to the original, you have to times the dilution, the amount of the dilution that you have done. So this is 10 times dilution. Okay, you'll have your original sample also. Okay, you also carry out a 10 times serial dilution. 10 times serial dilution, you pour plating, or 1 ml pour plate, and you get results. Okay, if you get let's just say you get this, so if you follow the first guideline, you only choose this. Okay, so there's no problem here. You follow the first guideline. First guideline says that the count has to be between 30 to 300. So this is the only one that is within range. So this is 10 power minus 1, 10 power minus 2, minus 3, minus 4, and minus 5. This is pore plating per mil. So the CFU per mil here will be 70 times 10 to the power 2. Okay, that will give you, so this is the concentration in the original sample. What if we have two plates that are within the range? What do? You can, what we do is we take both. Okay, this is 30, but it is as 10 times power negative 2. So we have to bring back to this dilution. So 300 plus, this is 10 times diluted from here. So you get the average of these two plates. So what you get is 300. Before you times the dilution factor, and you get your CFU. So if you have two plates that are within the range, you have to get the average. So I'll give you a different example. What if you get so what do? Still two plates within the range, you have to get the average. So the average will be, okay, although this is 30 CFU, but in order to get the average, you have to bring the value here to the same concentration here. Because this is a 10 times diluted sample, you have to times 10 here. Okay, so that's why you bring it down, and then you get the average. So your average will be 275. So once you get the average at this point, you can times the dilution factor. That will give you your final CFU per mil. Okay. So you have learned two things here. First, you have the counts you choose must be between the range 30 to 300. Okay, if there is only one plate that is within the range, then it is quite simple. But if there are two plates within the range, then you have to calculate the average. Okay, sometimes you have students who will ask, what if you have three plates within the range? But then this is quite impossible. If you see results like this, something must be wrong, because this is a 10 times zero dilution. You shouldn't be getting the same counts here. Okay, so 30 to 300 range shouldn't extend over 3 dilution factors. Okay, so probably this is a dilution error. Something went wrong when you are carrying out your dilution. If something went wrong like this, usually we'll stick with the lowest dilution, because that is where the least error comes in. Okay, so when you have your sample here and you carry out a 10 times zero dilution here, we'll be talking about how you calculate back when you pore plate, because pore plating usually will put 1 ml into the empty plate before we mix it with the molten agar. However, sometimes we do spread plating. Spread plating is where we put an inoculum of 0.1 ml on top of the agar, and then we spread the sample over the plate. Okay, so if you were to do a 0.1 ml spread plate and you obtain counts like for example this, okay, so what is the final CFU per mil? If you remember the first rule, only this plate is taken into account because this is within the range 30 to 300. So what is the concentration here? So this is 10 power minus 1, 10 power minus 2. Okay, 10 times 0 dilution. Okay, so the count here is 35 times 10 power 2. However, this is CFU per 0.1 mil of the inoculum. Okay. So because the final unit is CFU per mil, you have to calculate further. Okay. So it will be 35,000 CFU per mil. So that will be your final concentration for the original sample. Okay, so please take note of the inoculum. Okay, sometimes for spread plating, researchers will use 0.2 mil, and for pour plating also. All this also depends on the size of the plate. Okay, the standard plate will probably use 0.1 to 0.2 mil. However, you can have larger petri dishes. Okay, so please take note that these values, the volume of the inoculum, the concentration of the sample, will all affect your final CFU per mil. Okay, let's just take this case where you did a 10 times zero dilution, 1 ml of sample and 9 ml of diluent. Okay, so this will give you a 10 minus 1, 10 minus 2, and 10 minus 3 concentration. Assuming you have counts after incubation of 300, 70, and 7. Okay, so if you use the first guideline that says between 30 to 300, you will have to take the average of these two. Okay, but if you notice the count here is a bit too high. So how high do you consider? How much will you consider it to be high? So this is where the second guideline comes in. That is the count ratio above 2. Okay, so if the count ratio is above 2, you take the counts from the lower dilution. Okay, how do you calculate this count ratio? So you have 300 here and you have 70 here. So your 70 is at 10 minus 2. If you bring it down here, it will be 700. So 700 divided by 300, that will give you a count ratio. And if you notice, this is above 2. So whenever the count ratio is more than 2, you only take the CFU from the lower dilution. So the final concentration here is actually 300 times 10 power 10 times 10 for this 10 times dilution. So CFU per mil. Okay, this is assuming we are using pour plating. Okay, so this is where count ratio comes in. So count ratio comes in only after taking into account the first guideline, which is counts have to be between 30 to 300. If this is fulfilled, only then you check if the count ratio is out. Okay, if the count ratio is above 2, you do not take the average, but you take only the lower dilution. Okay, sometimes when you working with environmental samples, you will find bacteria that spreads or covers a large portion of your area. So if your bacterial spread, the spreader, covers more than 50% of your plate, then you can actually report your results as spreader. Okay. You get plates where there are no counts at all. If you are certain that there should be counts, should be colonies growing, but you are not seeing them, then you have to check for inhibitory substances in your sample. Okay. For a normal petri dish is about 56 cm squared. So if the number of colonies within a 1 cm squared is less than 10, okay, so you are supposed to count 6 boxes across vertical and also 6 boxes horizontal. Okay. If your colony is more than 10 per cm squared, you need to count only 4 boxes. However, if your counts are more than 100 CFU per cm squared, then you should report as more than 5600. Okay. So theoretically, the maximum CFU that you can see on a normal petri dish plate is 56,000. No, 5,600. If you count the CFU and you obtain 5,200 CFU, then you can report it as 5,200 CFU estimated. Okay, estimated CFU per mil. Okay, if your count is 5,700 CFU, the number of colony on your plate, then you have to report it as more than 5,600 estimated CFU per mil. So theoretically, this is the maximum number of colonies you can find on your plate. You diluted your sample 10 times zero dilution, pour plating. Okay, let's just say you got 6,000 colonies here. Oh no, let's just say you obtained TNTC, too numerous to count, too numerous to count, too numerous to count, and then because it is a waste if you do not attempt to count your plates. Let's just say you manage to divide your plate up and count about 5,800 colonies here. Okay. Then on another occasion you calculated 5,200. So how do you report this? So for case number 1, okay, for case number 1, you have to report it as more than 5,600. The dilution factor is -1, -2, -3, -4. So you times power 4. Estimated CFU per mil. For case number 2, your colony, the number of colonies formed on your plate is still less than the theoretical 5,600. So you can report it as 5,200 times 10 to the power 4 EST CFU per mil. You include the word estimated whenever your counts are outside this range. Okay? So once your counts are outside this range, you include this term, estimated. This is to show the one reading your report that the number of CFU you obtained were outside this range. Okay, so this is what you do when your counts are a lot. But what do you do if your counts are very little? Okay, so all these are less than outside your range of 30 to 300. So what do? So you report this as 20 times 10 power 1. That's the dilution factor. But you have to include this in. Okay? You include the term estimated to show people that your count here is outside the 30 to 300 range. Okay? What if you have okay? So which one do? You still choose the one nearest to 30. So it will be 24 times 10 power 1 estimated CFU per mil. Okay? What if all your counts are 0? What if you do not get any counts at all? Okay? So if you do not get any counts, you have to think in terms of the smallest number. So the smallest number that you can obtain is here, 1. So if it's here, it will be 1 times 10 power 1 estimated CFU per mil. So because you didn't get any count, it will be less than 1 times 10 power 1 estimated CFU per mil. Okay, so this is the count when you do not get any CFU measurements. What if you did not do this dilution? What if you did not do this plating? So what will your result be? Your result will be what is the lowest count that you can get? The lowest count you can get is here. Okay, so that means it is 1 times 10 power 2 EST CFU per mil less than. Okay, because you are getting 0. Okay, so that's how you handle your CFU counts that are 0.